Now I'm going to talk about second law of Kepler. Kepler's second law says the angular momentum is constant in a central field. You will see in a minute what the central field means. Central field, essentially, you have a force. Let's say here you have a center. The force always point towards center. There are two examples. One of these is just like Coulomb's force act on the charge. If the charge moving like circle and then it's point towards center. There's another example which you see in a minute. That will be gravitational force. Same thing here. Remember, this time we have the angular momentum is constant. In other words, L dot is going to equal 0. Okay, so that's what you're going to see that. And we're going to prove it in a minute. So for the moment, let's take derivative with respect to with respect to time. When you take derivative, you have two terms. One is from r, second term from p. So that's why these two terms comes out. Now, you see in class we talk about r dot r, right? You remember r dot r, that's the radius constant, the velocity of speed is constant in these cases. Now you see a cross product. P cross another p. The reason why this p comes out is because if you dot, this is the velocity, r dot is velocity, so you have the velocity just equals the momentum divided by mass. So p dot cross p is equal to 0. So therefore the first term is going to be 0. Second term, which is very interesting, you can see the cross product r cross p dot. P dot is just a force, right? What we used is dp over dt is just a force. And in lower level class, we talk about F time the time. This is usually called impulse. Now you can see the angular momentum change just equals r cross F. And this is the key equation which we're going to address and use them in the next few part of that. So now let's move on to the central field. And this real things start. Central field, what that means is that the field itself is pointed towards center. So what that mathematical means. So here is the force if force is a central field, which means the r cross product with the F is going to be equal to 0. So this means that the force direction, r direction, is in the same direction or opposite direction. So 0 degrees or 180 degrees. So that's what means central field. Let me show you a diagram, what that means. Here is the force, here is the radius. They're in the same direction or opposite direction. Doesn't matter. The cross product is going to be 0. So this cross product is going to be 0. Now you can see the orbital angular momentum change, which is L dot, just equals r cross F. If these two in the same direction or opposite direction, so therefore this has to be 0. So what that means is that L dot equals 0. So which we say L is constant. And this is the this what that means is that r cross the momentum m times v is going to be constant. In other words, r cross v is going to be constant vector. Now remember, this term is not constant, scalar. You remember in class we talk about r dot another r equals r squared, or v dot another v squared. This is this constant velocity. Here we have, in this case, a constant scalar. Now we have constant vector. So in other words, r cross v will be equals in a fixed plane. In other words, whatever this product is going to give you is going to fixed plane. Let's go like that. Let's go like that. They may not be perpendicular to each other. But at least we know that this cross product, if you use a right-hand rule, you r cross v, so that's the arrow is a point toward us, and that is where the Kepler's second law is about. So next video, I'm going to show you a little more.